In this next section, we're going to review various periodic trends that exist in the periodic table. As a reminder, like charges, so positive and positive or negative and negative, will repel one another, and opposite charges, like positive protons in the nucleus and negative electrons surrounding it, will attract. The positive protons are attracted to the negative electrons. The negative electrons, on the other hand, are repelled by neighboring electrons that are also surrounding that nucleus. All right, as a reminder from the physics portion of your review, Niels Bohr used the idea of energy quantization, placing electrons in specific energy levels. These ideas were also used later by Schrödinger in the quantum mechanical model of the atom. This is important in how the periodic trends lay out across each period and down each group. So every time you move down a row in the periodic table, another energy level is used. So the first row of the periodic table, where we would have hydrogen and helium, those electrons only occupy the first energy level. The next row would occupy the second. The third row of the periodic table would occupy this third energy level. And electrons that are located in higher energy levels are located further from the nucleus. So those last electrons for those elements in the third row of the periodic table, their electrons are way out here, much further from this positive nucleus. All right, so what are the trends that we see in the periodic table as it relates to atomic radius? Atomic radius being the distance of the atom's radius from the nucleus in its center to the outermost part of that electron cloud. So moving across a period from left to right, you're adding one proton each time. So the nucleus is getting more protons, and you're also adding an electron. So you have more electric force pulling the electrons into the atom. That force between the positive nucleus and the negative electrons surrounding gets bigger. As a result, those electrons are more attracted to the nucleus. They kind of pull in a little bit. And as a result, atoms get smaller moving across the period. Conversely, as you move down a group, so from the first row to the second row to the third row to the fourth row in a group, you're adding energy levels. So row 1 is n equals 1, row 2 is n equals 2, and so on. As such, electrons are then getting positioned further and further away from the nucleus, resulting in atoms getting larger as you move down a group. In general, on the periodic table, the closer an atom is to helium, or that top right corner of the periodic table, the smaller it is. And the closer an atom is to cesium, or towards that bottom left corner of the periodic table, the larger it is. Here's an image that just sort of shows visually what we just described. So we can see that as you move from left to right, in general, the radius gets smaller. And as you move from top to bottom, the radius gets larger. And that, in general, towards the top right corner of the periodic table, the atomic radius is smaller, and it increases as you go down and to the left. So there are a couple of different ways that you can write this on your periodic table as a reference. You could say that from left to right, the atomic radius decreases, and from top to bottom, the atomic radius increases. Or you could just generally say that from this bottom left to this top right corner, in general, you get a decreasing atomic radius.